Good morning to our lecturer Encik Muhammad Rizwan bin Danari and all my friends. My name is Devram Alaki Sri Ramalingam Sami, metric card number 01 TKP24F2004 and from the class of TKP2. And today my presentation is on workshop safety and health, specifically focusing on workshop management tasks. So, what are we going to cover today? By the end of this presentation, we will be able to define management tasks, to define workshop management tasks, and identify their core function. Analyze international standard to analyze the role of an international standard ISO 45001 for this task. Third, analyze national standard, which is Malaysian standards, to analyze the role of Malaysian standard under Malaysian law, OSHA 1994. And lastly, analyze institutional standard by from Polytechnic Nkoma to analyze where you need to analyze the role of institutional standard by Polytechnic Nkoma. Okay, let's start with the introduction. A metal fabrication workshop is a high risk environment. We all know where we are working with heavy machineries, high temperature welding, rotating equipment, and electrical system. The most important thing to remember is that safety is not a passive state. It's not just being careful, it's an active process that must be continuously managed. These management tasks are how we, as future engineers, will fulfill our professional, ethical, and legal responsibilities. So, what are these tasks? My report covers four core workshop management tasks that every engineer is responsible for. The first one I'll be talking about production planning and scheduling. For production planning and scheduling, the engineer must plan the workflow with safety in mind. Why? It's because poor planning leads to rushing, and rushing is a major cause of accidents. Good planning ensures there is enough time for safety checks and proper machine setup. Second, I'll be talking for training and supervision. The engineer is responsible for their team competency. This means comprehensive safety training for new employees and ongoing supervision. The goal is very simple. No individual should ever operate equipment without being proven competent and aware of all the risk. Next is task 3, which is risk assessment control. This is the most proactive safety task. It's not about reacting to accident, it's about preventing them. We must systematically identify hazards, evaluate the risk and implement controls to stop it. In Malaysia, we have a clear process for this, which is known as HIRARC, which stands for Hazard Identification, Risk Assessment and Risk Control. In Malaysia, we use the standard process known as HIRARC, which stands for Hazard Identification, Risk Assessment, and Risk Control. Okay, let's look at this process on the screen that I've given. So first, we classify work activities. We list down all the tasks and jobs that happen in the workshop. Second, consultation. This is critical. The engineer must talk to both employer representative and the worker representative. Why? Because the worker who do the job every day often know the real hazards better than anyone. Third, we identify the hazards. Based on the consultation, we find everything that could possibly cause harm, like a missing machine guard, a chemical spill, or fried electrical wire. Fourth, risk assessment. This is where we ask how bad is it? We evaluate the level of risk. Is it a small risk or high priority danger? Fifth, we prepare a risk control action plan. This is where we decide what to do about it. Do we eliminate the hazard or do we add a warning sign? Do we provide new PPE? So these are the questions we need to ask as as a action control action plan. So after that we make a plan from it. Sixth, we implement the plan. We put those control in action. Finally, review. As you can see by by the arrow going back up. This is a continuous cycle. We must review our control to make sure they are working and see if any new hazards have appeared. And the fourth task is maintenance and resources. Maintenance is about the physical integrity of the workshop. The engineer must schedule preventive maintenance on all machinery to prevent dangerous equipment failures. Resources, meaning managing our PPE, which is known as personal protective equipment. The engineer must ensure all necessary PPE is available, that it is compliant with standards, and that that it is in good condition. Now, let's look at the standards at the international level. We have ISO 45001. This is the global benchmark for occupational health and safety. It is not a law, but it's the best practice that represent our professional ethics. It is based on PDCA cycle: plan, do, check, and act for continuous improvement. Where plan stands for identify hazards, do stands for provide resources and training, check stands for monitor performance through audits, and act is investigate incidents to stop them from happening again. Now let's look Now let's look at the standards at the international level. We have ISO 45001. This is the global benchmark for occupational health and safety. It's not a law, but it's the best practice that represent our professional ethics. The entire standard is based on PDCA cycle, which stands for plan, do, check, and act. This is a model for continuous improvement. Let's break it down. First is plan, the blue box. This is where we set up the system. Clause 4 and 5 is about understanding the context of organization and ensuring leadership buys in. Clause 6 is planning itself, identifying risk, opportunities, and legal objectives. Next is do, the green box. This is where we put the plan into action. Clause 7 is support, providing resources, training, and communication needed. Clause 8 is operation. This is the day-to-day running of the plan, managing control, contractors, and being ready for emergencies. Then we check, which is the yellow box. We see if plan is actually working. Clause 9 is performance evaluation. This means monitoring of progress, checking KPIs. KPI stands for Key Performance Indicators, conducting audits and reviewing with the results. Finally, we act, which is the red box. This is how we improve. Clause 10 is improvement. When an incident happens, we investigate it, we learn from it, and we update our plan to prevent it from happening again. As you can see, the arrows, this cycle never stops. You plan, you do it, you check your results, you act to improve, and then you start planning all over again. This is how we create a culture of continuous safety improvement. More importantly, for us in Malaysia, we have our national standards, the Occupational Safety and Health Act 1994, or it is also known as OSHA 1994. This law is based on self regulation, which puts the main responsibility for safety on the employer and the manager. There are three sections to remember. Section 15, the general duty to ensure the safety and welfare of all employees. Section 16, the legal requirement to have a written safety policy. And Section 32, the legal duty to notify DOSH, which is known as Department of Occupational Safety and Health, immediately if there is an incident. Lastly, there is institutional standard from Polytechnic Nkoma. So how does this all apply to us as students at PUO? First, the training duty. Our lecturer act as the engineers. They enforce this by making sure all students go through the lab sheets and get authorized before we can use any machinery, like a lathe machine or welding set. Second, the safe system of work. We follow rules in the Buku Panduan Plaza. This means wearing our mandatory PPE, protective personal equipment, like safety shoes, safety glasses, coveralls, and cotton gloves, and keeping all walkways and emergency exits clear. And finally, safety signage. We must observe and obey all the mandatory safety signs in the workshop. Alright, on this slide, you see a collection of mandatory safety signs. These are the exact type of sign required in high-risk environments. As you can clearly see, the main theme is danger and high voltage. If we look closer, these signs aren't all the same. They have very specific jobs. First, they warn of a hazard. We see general signs like danger, high voltage, and high voltage above. Second, they give clear instruction. This is the most important part. We see keep out, keep away, and do not remove this barrier. They tell you exactly what to do or what not to do. Third, they specify the danger. Some sign give more details like hazardous voltage inside or energized equipment near ground level. Fourth, they control access. A key safety control is limiting who is at risk. Signs like electrical equipment, authorized personnel only, are a legal requirement. Finally, they warn of other hazards. It's not just high voltage. We also see critical signs like no trespassing, do not operate, man working on repairs, which is a vital part of lockout tagout procedures. So the purpose of this sign is clearly and quickly communicate risk and control access to keep everyone safe. In conclusion, effective workshop management is the bridge between written laws and our physical safety on the workshop floor. By performing these core tasks, planning, training, risk assessment, and maintenance, we are fulfilling the professional and legal responsibilities required by our industry. This is how we create a true culture of safety. This is all for my presentation. Thank you to my lecturer, J. Mohammad Redzwan bin Danuri, for letting me to present my presentation and to all of my friends. Thank you.